Hey everybody, in this unit, we're going to talk about regression techniques. Regression techniques are one of the most popular statistical techniques that are used for predictive modeling. Typically, analytics professionals use about two to three types of regression. Um, they are linear, logistic, and polynomial regression. Those are the typically used ones. But there are more than 10 types of regression algorithms that are designed for different kinds of analysis. Each type is suited for a specific need, and it's good to know the form of regression that you want to use based on the data and the distribution that's out there. So, what is regression? Regression is nothing but a statistical relationship between two or more variables. When where there is a change, um, so there is an independent variable and there is a dependent variable. So the independent variable is will impact the dependent is impacted by the dependent variable. The change in the independent variable is associated with a change in the dependent variable. So let's look at linear regression, which is what you're seeing on the screen here. A linear regression is the simplest form of regression. It is a technique in which the dependent variable is continuous in nature, as you can see in the graphic here. The the plot shows a kind of a linear relationship between the mileage and the displacement of cars in here. The green points that you see are the actual observations, and the black line is fitted, and it is the line of regression. It's fitted into those points that you have the observations that you see in here, and it's typically represented as y equals mx plus b, where that's the dependency that you have between the two variables. And the other kind of regression that we will typically encounter in our analysis is a polynomial regression. This is a technique to fit a nonlinear equation by taking polynomial functions of a dependent variable. Uh, as you can see in the figure given below, you can see that the red curve actually fits the data better than the green curve. The next kind we want to talk about is the logistic regression. And what is logistic regression? It's nothing but with logistic regression, the dependent variable is binary in nature. You only have two categories. As you can see in here, the probability is either of something happening is either 0 or 1. It's either going to happen or not going to happen. Uh, Typically, in these scenarios, is when you would use the logistic regression model. Without further ado, let's get into our RStudio and see how we can actually fit models to the data. First off, I want to install a few packages One is G Galley, and I want to install a package called Mosaic. This one will take some time to install, so just bear with it. The other package I'm gonna install is ggraph extra. These are handy packages to do the analysis on the data and to figure out the model that you want to use. So bear with it as the packages are getting installed. Now we have the necessary packages installed. So the first thing we want to do is, so we're going to look at the iris data. Hope you can see my screen. I'm going to move my panes here, and much better. So run this command called gg pairs on the iris data set. And this is part of the gcali package. I need to use the gcali library, and it requires ggplot2, which we had installed earlier. Now we can use gg pairs. Let me zoom this here. This gives a good insight into our data. The pairs plot here, it gives insight into the data and demonstrates how the different variables are related to each other. As you can see here, you can see the plots, and you can see how petal length and petal width are closely related. So you can see that we plotted a linear model here. And so here you can see, looking at the p-values here, right, that this simple model seems to fit the data really well. Now let's explore a logistic regression model here, again with iris data. I have copied the code here in the interest of time, so I don't have to type these as you're watching. So what we're doing here is taking the first 100 records of the iris data set, because those are the ones that have the setosa and the versicolor records. And what I did was splitting the sample into a control set and a test set. You can do a GG pairs with the test set. Zoom it in. You can see that. And do a GL fit with species and sepal length. When I do a GL fit and do the summary of the GL fit, we can see that the p-values indicate highly significant results for this model, which you can see in here. Now jumping into the actual model itself to see the probability. And you can see the probability in here of the model, and do a plot. Which should give the regression model here, the logistic regression model. And as you can see, there are some that have bled into the other sides, but for most of the part, you can see where setosa and the versicolor species fall.